Hi guys, we continue with the unit 1, the requirements engineering. Now we are focused on the analysis and synthesis of information. The last video about the requirements gathering techniques, we learned about some of these techniques, and now with the requirements that we obtain of that one of the techniques we use for the analysis and synthesis of the information. To start with the analysis of the information, we need to know about the types of requirements. It is important for the requirements engineer to settle on definitions of the types of requirements that he will use consistently. He should advocate consistently meanings for these types on his project and his organization. Much confusion can be avoided by agreeing on a set of definitions and by not using certain terms. A requirement is a statement that identifies a capability, a feature, or quality factor of a system in order for it to have value and utility for a user. A requirement is well defined and more specific than a need, which is capability decided, which is a capability decided by a user or customer to solve a problem or achieve an objective. The purpose of this process area is to elicit, stimulate, analyze, and communicate customer and user needs and expectations and translate them into a verifiable set of requirements. We have some types of requirements, and we start with the business requirements. The business requirements are the reason for developing systems and software in the first place. Business requirements are the essential activities of an enterprise. Business requirements are derived from business goals, and then the business scenarios may be used as a technique for understanding business requirements. A key factor in the success of a system is the extent to which the system supports the business requirements and facilitates an organization in achieving them. If our system or software don't support the business requirements effectively and efficiently, they have no reason for being. Business exists to make money for stakeholders. Organization exists to meet the needs of their members. It is vital that we consider our system and software development work thoroughly within the context of business and organization objectives. The second, the user requirements. Users are the individual or groups that use a system or software in its environment. User requirements are their verified needs for that system or software, and this is important. The next is the high level or system level requirements, or to understand the needs of the system. We refer to the high level or system level requirements. This term relates to those requirements that are foremost in importance, capture the vision of the customer, enable defining the scope of the system, and allow estimating the cost and schedule required to build the system. And it's important, or it's recommended, that a workable number of requirements system level requirements be identified for a large system, more or less 250 to 2000 requirements. It's important to identify in case that we are developing a big system. The next are the business rules that provide the basis for creating the functional requirements. They are as follows: the policies, conditions, and constraints of the business activities supported by the system, the decisions processes, guidelines, and controls behind the functional requirements, the definitions used by the business, relationships and workflows in the business, knowledge needed to perform actions, and the business rules must be captured explicitly by the person that are analyzing the business, and baseline during requirements analysis, focusing on business rules as the core functional requirements, speed requirements analysis, and promotes validation and verification. The next is the functional requirements. Functional requirements are an important category of the real requirements. Functional requirements describe what the system of software must do. A function is a useful capability provided by one or more components of a system. The functional requirements are sometimes called behavioral or operational requirements because they specify the inputs to the system and the outputs from the system, and behavioral relationships between them. In this case, it provides a detailed analysis of the data the system will be expected to manipulate. It may include a detailed definition of the user interface of the system. And the next is the non-functional requirements. The non-functional requirements specify system properties such as reliability and safety. And in the diagram we see a lot of non-functional requirements, and it's important to understand why we need to pay attention for this kind of requirements, because they impact in our analysis. The next type or the next requirement is the derived requirement. That is one that is further refined from a high-level requirement or a requirement that results from choosing a specific implementation or system element. All requirements are derived from the system need. Thus, the derived distinction tends to have little significance. However, many system engineers distinguish between externally identified requirements and requirements that are derived under the control of the engineer. The performance requirements, it's the next one of the most difficult challenge in system development. It's defining and meeting the performance requirements. The performance requirements define how well the functional requirements must perform. And the next is the interface requirements. Another difficult challenge in system development is finding and defining the interface requirements. Interface requirement analysis identifies physical and functional relationships among system elements and between system elements and the system environment. One project team member should be assigned principal responsibility for assuring coordination of interface requirements, and we have some tools or methodologies that are useful for this kind of requirements. For example, the UML with the class diagram. The next types of requirements is the verified requirements, that are real requirements that are met or satisfied in the design solution. The next is the validate requirements, that are requirements that are implemented in the delivered system. We have a clear definition of these terms, detailed information concerning how to use these fundamental problem-solving tools, and practical methods for each step of the process in the actual delivered system. And it's important to take note about how these requirements can be useful for the new system. The qualification requirements refers to the verification or validation of item performance in a specific application and results from design review, tests, data review, and configuration audits. The next one is the unknowable requirements. Experience has shown that there are requirements that are unknowable at the beginning of a system development effort. Some requirements become apparent only as the system evolves. We discover that some of these requirements, or that some requirements that we could not envision previously, and such notable requirements may be real requirements which must be included in of design or in our analysis. The product requirements, these are requirements of the products that are produced by a system. The process requirements are requirements that exist because of the processes being used to develop the system or software. The logistic support requirements are requirements that exist because of such things as tools, training, procedures, facilities, and spares. One often hears of them in reference of the integrated logistic support requirements. The next one is the environmental requirements. These are requirements that result from the physical setting and social and cultural conditions of the system development effort and the setting in which the system or software will be used. The next and the last is the system, subsystem, and components requirements. This refers to requirements associated with different level of the system. The system is the highest level and is divided into subsystems. The subsystems are made up of components such as hardware, software, training, and documentation. Now the requirements analysis. The analysis is the process used to examine, decompose, and synthesize information to further understanding and the features and capabilities of the solution. Throughout the analysis domain, requirements are captured in various formats and decomposed to obtain the necessary level of detail. Similar to elicitation, analysis is performed using a progressive and iterative approach to examine the information to lower levels of detail to develop a set of requirements. The iteration and analysis continue until a sufficient level of requirements needed to formulate the solution is obtained. The requirement analysis success factors are three. There are the skill resources, that is, having the correct talent is vital to conducting meaningful analysis. Once the process has started, there is little opportunity to train and acquire the right skills set to effectively perform analysis. The second one is the communication. Thorough analysis, frequent and timely communication with the project team, stakeholders, etc. is key to improving the quality of the requirements. This communication helps to further clarify uncertainties and avoid costly rework in downstream domains. And that is the reason, because communication is one of the most important success factors in the requirements analysis. The last one is the collaboration. The success of analysis greatly depends on establishing a collaborative working relationship between the stakeholders involved in the requirements effort and the person performing the analysis. This environment enables open and effective communication that may foster the discovery of stakeholder expectations that should be better during the refinement of the requirements. And for this we have requirement analysis activities. The analysis plays a crucial role in confirming that the requirements are complete, accurate, and aligned with the business goals and objectives, of course. In practice, analysis is performed using the output from requirements elicitation and includes planning, analyzing, and documenting the results. For this, we need a plan for analysis. It is essential to establish a strategy for how analysis will be performed. This strategy includes determining what activities and techniques will be used to yield the greatest benefits based on what is known about the project or program. Analysis planning also involves defining which tools to apply and how the outputs will be documented. The activities and techniques executed during this requirements analysis are governed by the requirements management plan. However, activities may be redefined and adjusted as more details are discovered throughout the project. Planning for effective requirements analysis also relies on careful review and consideration of additional factors. The second one is the conduct analysis activities, but we have some specific points to view. The conduct analysis activities. Requirements analysis is more than analyzing information to further understand it, complete it, and improve it. It involves structuring requirements in different views to capture varying perspectives, evaluating requirements for certain attributes, and integrating the collective information into writing documentation. Requirements analysis is a continuous process, and the first step is identify, analyze, and document requirements attributes. Requirements attributes are specific features or traits that capture key information about a requirement, such as source, owner, priority, complexity, rationale, and status. Requirement attributes are elicited as requirements are elicited. This information is used to aid in requirements traceability and monitoring throughout the project life cycle. Specifying attributes is crucial to the analysis process, as the information can be filtered, sorted, and validated to reveal discrepancies that may require additional analysis. The second is to select the requirements models. A component of analysis is the development of graphical or text models, which are helpful in finding gaps in information and identifying extraneous information. Requirements are modeled and refined to provide greater insight and correctness, and they elicit additional information to define the details necessary to build the product, service, or result. As some models are better suited from certain environments, it is important to select requirements model based on specific characteristics, type of project, methodology, time, purpose, and level of abstraction. Requirements models are constructed at various levels of detail. The third point is to prioritize requirements. Requirements prioritization is an important step in managing product scope and is used to rank requirements in the order of importance. It is used to assist key stakeholders in making trade-offs between requirements and to analyze the relative value of requirements against one another. Since it may not be feasible to implement all requirements within the project constraint, prioritization helps to focus the stakeholders on the most critical requirements based on the prioritization criteria. It is essential to define the criteria that will be used in prioritization, and this is typically accomplished during requirements management planning. Common types of criteria include value, risk level, complexity, cost, and regulatory constraints. The next point is to allocate and derive requirements. Requirements allocation is the process of assigning requirements to functions, solution components, and organizational entities. Requirements are subsequently allocated to specific releases or iterations. This activity occurs in the analysis process until in-scope requirements have been apportioned across the solution. Allocation helps assure that the proposed solution will be delivered in a manner and order that maximize value to the business. How requirements are allocated can change the amount of value delivered by the solution. Delivering requirements is the process of analyzing requirements into more detail to extrapolate more granular, discrete requirements and remove ambiguity. When requirements are broadly defined, they should be progressively elaborated to a greater level of detail or decomposed into multiple discrete requirements to aid in the implementation of high-level requirements or to reduce ambiguity. This process results in derived requirements, which are important to confirm that the required functionality is present. It provides the basis for subsequent verification and validation. And then verify requirements. The requirements should be scrutinized to confirm integrity and ensure that quality standards are being met. Requirements verification is a process of reviewing requirements to ensure the requirements are constructed properly and are error-free. Requirements verification involves conducting peer reviews and inspections to detect errors and identify inconsistencies in the requirements in order to meet quality standards. A successful verification process requires that specific quality characteristics are known and adhered to. These characteristics serve as a set of guidelines when reviewing requirements to ensure they are of high quality. The following characteristics are present in all well-written high-quality requirements. They need to be unambiguous, consistent, correct, complete, measurable, feasible, traceable, precise, testable, independent, negotiable, valuable, estimable, small, and testable. The last six are or apply for adaptive life cycle, and the last point of the conduct analysis activities is the validate requirements. Requirements are validated to ensure that the product, service, or result represents the needs of the business and relevant stakeholders. Validation is a process used to evaluate that all requirements accurately reflects the intent of the stakeholder, thereby ensuring requirements meet the stakeholder expectations. Validation is typically performed by conducting a walkthrough of the requirements with the stakeholder to confirm the requirements as stated are valid and will deliver the anticipated value. And the last step in the requirements analysis activities is the document and communicate results. Analysis is conducted with the intent of documenting the results in an accessible and consistent manner to meet the needs of the intended audience and the project life cycle being used. This documentation is developed in accordance with the requirements management plan, which defines the requirements that define the solution scope to address the business problem or opportunity. This documentation is used by the solution team so that the team understands how to build the solution. The requirement documentation may be created in various forms and levels of formality, such as specifications, written text, models, etc. These different representations should be selected based on the type of project life cycle, organizational or industry practices, and stakeholder preference, of course. For example, projects using adaptive or agile or lean methodologies favor and less extensive requirements specification because the development environment is more collaborative and can use conversations over documentations that are one named or one thing that is important in an agile methodology that we are studying later in this course. But for now it's important to understand that this kind of methodology it's less or require a less documentation than others. And that's it. See you guys, and remember, proudly UTR.